Alright everyone, today we're going to be talking about tessellations, and we're going to explore what shapes make good tessellations and which don't. So, as we talked about in the intro, we discussed how regular hexagons make good tessellations. So now I'm going to take a second and I'm going to, in GeoGebra, create a hexagon and make tessellations for it. So as you guys can see, we've created a tessellation now with a regular hexagon. This red hexagon in the middle is what we started out with, and then we tessellated all around it. As you guys can see, we can kind of keep going, and each hexagon will fit in nicely with the other hexagons around it. Now what we're going to do is we're going to take a look at some other shapes and see if they have similar properties. So first we're going to start off with triangles. Just as a review, if you're following along at home and want to create your own tessellations, what you do in GeoGebra is you scroll down until we find the polygon section. Okay, and then we find regular polygon, and we just select a distance, and we can type in however many vertices we want. So since we want a triangle, we'll type in 3. And here's our triangle. Now what we do is we select 2 points on that triangle, and we create another triangle right off of it. For the sake of demonstration, I'll change this triangle to be our starting red one. As you guys can see with our finished product, triangles also tessellate. So now what we're going to do is we're going to look at a 4-sided shape with a square. As we can see, squares also tessellate very nicely. They're actually, when you're graphing on GeoGebra, we can see how nicely they fit in with our grid lines. Now let's move on to a 5-sided shape with a pentagon. This one I'm going to do on camera so we can see it in action. So we're going to use our regular polygons tool, and I've already created one pentagon. Now we're just going to create some more. So pentagons have 5 vertices, so we're going to keep going. Let's create a few. I'm actually going to go all the way around this pentagon so we get the full example. So, even though this looks kind of pretty and it looks like a flower, we can see that there's actually some space in between each gap. And if we try to make a pentagon on this side, for instance, it overlaps. There's not really a good tessellation shape. For septagons, we're also going to do the same thing. So we're going to take our regular polygon tool. We're going to create some more septagons with 7 sides. And as you guys will start to notice, instead of being any areas that don't have any coverage, we actually have overlapping areas now. And these aren't good either. We want our shapes to fit in nicely and perfectly within each of them. And we don't want any area to be overlapping or underlapping, as I like to call it. So even though we have this nice pretty flower shape again, it's not really a complete tessellation. Just to nail it all home, I've created a comparison up here at the top with 2 different tessellations between a regular pentagon and a regular hexagon. So if you guys can see, I can take these 2 points and actually can change the distance of the tessellation, and no matter how small I get or how big I get, the tessellation still doesn't work. Whereas with the hexagon, any size it is, and any location, I can move it around, the tessellation will always work. The reason for this is because equilateral triangles, regular squares, and regular hexagons all have interior angles whose measures are factors of 360 degrees, like 60, 90, and 120. Pentagons and septagons, however, have angles that are measures that are not factors of 360 degrees, like 108 and 128 in a lot of decimals, so that's not even a whole number. The reason for 360 degrees, however, is because when we're creating tessellations, we're essentially creating larger and larger circles around our initial shape. So that's why we need our interior angles to be factors of 360 degrees. I hope you guys learned something new and enjoyed the video.